Hi, chemistry students. Today we're going to talk about the enthalpy, which is the heat that a chemical reaction is involved with. So you've all experienced endothermic reactions and exothermic reactions. An example of an exothermic reaction would be like a hand warmer, how it warms your hand up. That's caused by a chemical reaction. And you've probably experienced an endothermic reaction if you've ever mixed baking soda and vinegar together. The container that you mix it in will feel cool to the touch because it is actually absorbing heat. So an endothermic reaction absorbs heat, an exothermic reaction gives off heat. We're going to explain in much more detail in the coming worksheets and videos that I'm planning on doing, how to measure all that and how to calculate it. And there's different ways of calculating it. So this first lab we're going to do, it's in their lab packet. It's Chapter 14, Lab 1, measuring delta H. Delta H stands for change in enthalpy. And like I say, we'll be talking more about what that means. But we're going to do a reaction here. I'm going to do it for you. What I'd like you to do is take the numbers that I am actually using to do your calculations. This is not a good experiment to do it at home by yourself because we're going to use sodium hydroxide, which is caustic to the skin, and you might not have any at home anyway. So I'm going to do the experiment. I am going to tell you the measurements as we go through, and you can record those. You can start and stop the video whenever you want if you miss anything. So the first thing we're going to do is turn on the mass scale. So I've got a scale just like we use in class. I'm going to turn it on. And this is my calorimeter, 2 cups, styrofoam cups nested together. I'm going to take the top one out, put it on the scale, and tare it. Oh, actually I'm going to tare it first because what I'm wanting to do is determining the mass of this is going to be my calorimeter. So I'm going to determine its mass, and it's 1.9 grams. So on your data sheet, in your step 2, that is the mass of the top cup. Okay, so now I'm going to keep the cup on the scale, and I'm going to tare it again because what I'm wanting to do is weigh out my vinegar. This is my vinegar. I'm going to weigh out 115 to 125 grams. So I'm just going to do that. It doesn't have to be an exact number, just anywhere as long as you're in that range. All right, I'm going to stop there. 118.3 grams. So on your data sheet, that is going to be the mass of the vinegar from step 4. All right, step 5. Put the lid and thermometer on the calorimeter. So I'm going to put this top cup into my bottom cup. This is my calorimeter. I just have the thermometer with the cardboard cutout circle here, and that's going to keep the heat in, so my measurements will be more exact. I'm going to put that in my calorimeter. Now you want to be careful that the bottom of the thermometer is not touching the bottom of the cup. So it needs to be suspended in the liquid, but not touching the bottom of the cup. So I'm just going to adjust that. Adjust that. Okay, so I'm going to let that sit for a little bit so we can get an accurate temperature when we start. Whatever temperature is going to be here when I'm ready to start, that's going to be my initial temperature. So these calculations we're doing are very similar to what we did in Chapter 13, only we're just measuring, instead of specific heat capacity, we're actually measuring how much heat is given off. Okay, so we're ready for step 7. So I'm going to wear my gloves for this, because this is sodium hydroxide, which can burn your skin if you remember. and I need to measure between 2.5 and 3.0 grams. So I'm going to put this little cup on here. I'm going to turn on my scale. I'm going to put this on and then tare it. Okay, and I'm going to put in 2.5 to 3.0 grams. Again, it doesn't need to be any exact number as long as it's in that range. Oops, I got too much. So I'm going to pour some out. I'm not going to pour it directly into the container. I'm going to let it, put it in the lid. Okay, 2.8 grams. So that's the quantity of sodium hydroxide we're starting with. That's step 7. Okay. So now what I'm going to do is I'm going to take my reading of my vinegar in my calorimeter. So the temperature reading that I'm going to take is going to be the initial temperature of both the vinegar and the calorimeter. And it is reading about 19.8 degrees Celsius. 19.8 degrees Celsius. That's going to be step 8. That's your initial temperature. Okay, now I'm going to cause the reaction to occur. I'm going to take the lid off the calorimeter and I'm going to put the sodium hydroxide in the vinegar. And you should immediately start seeing the temperature rise. This is an exothermic reaction. The temperature is going to rise. What I want to do is keep watching the thermometer until it reaches the highest temperature before it starts going down. So the highest temperature it reaches, that will be the point where I need to record the temperature. I'm going to add this to this. A little bit of experimental air there because there's a few grains of sodium hydroxide left in the cup. Okay, so I'm going to use my thermometer to stir it, or just kind of swirl it. It's up to 21 degrees. It's still going up. You're going to learn in this chapter there's 3 ways to determine enthalpy. This is one way, and it's the most time-consuming. We're up to 22 degrees. $22.5. $23. Just pointing out a few sources of air here. I've got a couple drops that fell into my tray. Whoops. And also, if the lid comes off, that allows some heat to escape. We're up to 27.5. Looks like it's pretty much stopped, maybe going back down. Let me wait another minute maybe. Yeah, the temperatures looks like it might be reached its peak. Maybe not. Yeah, we're going to call the ending temperature 27.5 degrees Celsius. So that would be step 11 on your worksheet. So that's it. That's how to perform that experiment. Now, all the data that you have, you should be able to determine how much heat that actual reaction produced. So knowing this kind of thing is important when you think about one of the biggest kinds of exothermic reactions are fires and things that heat your house. So it's to be the most efficient heat source, they want to get those products that make the most enthalpy. So that's it. We'll see you next time.